Children, so today we are going to learn about how to balance chemical equation. Okay, so this doubt has come. Now, what do you mean by chemical equation? So, chemical equation is actually the symbolic representation of any chemical reaction which is taking place. So, it is for our easy interpretation or understanding. The chemical reaction is written symbolically. Okay, so see how it is happening. Suppose this chemical reaction is there in front of you, wherein magnesium is reacting in presence of air and forms magnesium oxide. So in this reaction, if you write magnesium, okay, plus oxygen. Why oxygen? Because you are aware of that here magnesium and oxygen are going to react together to form magnesium oxide. How do we know that oxygen is going to react? Because we are aware of air is composed of oxygen, nitrogen and other gases. Okay, carbon dioxide is also there, but it is very less in amount. So maximum oxygen is only going to react because nitrogen is inert over here, it doesn't react with magnesium. So now here magnesium is going to react with oxygen to form magnesium oxide. Now in this case what we have to understand, here this is said to be word equation because we are writing names of each element and the compound which has formed. Magnesium plus oxygen, this arrow shows forward chemical reaction. So it is forming magnesium oxide which is a compound. Okay. So now if we understand here how symbolically we can write it. So you know that symbol for magnesium is going to be Mg. For oxygen it is going to be O, but oxygen being non-metal it cannot exist in monoatomic form. So in air it is available in the form of oxygen molecule. So we will write O2. Okay, how O2 is formed? That we have already done in covalent bond formation. It is forming covalent bond between two atoms of oxygen. Okay. Now the compound which is forming is magnesium oxide. So here it is magnesium oxide. Now you understand, on left hand side of this arrow is called reactant, on right hand side of this arrow is called product. Okay. So this is reactant and this is product. So according to law of conservation of mass, mass can neither be created nor be destroyed. So here whatever mass is there on left hand side, same mass should be there on right hand side. So if you talk about mass on reactant side, for magnesium it is 24 plus oxygen, mass of oxygen is 16. Since it is 2 times, it is going to become 16 multiplied by 2. So in total, how much it is going to be? It is 24 plus 32, which is going to give you how much value? This is going to be 56. If you talk about product side here, so mass of magnesium is 24, mass of oxygen is 16. So on right hand side or on product side, if you see, it is how much? It is going to be 40 only. So you see, it is not equal. Masses must be equal on both the side. Okay, that is why we have to balance it, because whatever amount you are using, that same should come in product side. Now see how we can balance this chemical equation. For this thing, what we will write here, first you write down what elements are involved in that. So elements, if you see, okay, so here which elements are there? You will say magnesium and oxygen. Now on reactant side, Here we are putting reactant side as well as the product side. This table we are making just to tally how many atoms of different elements are present. We can do it directly also by hit and trial method, but for better understanding we are using this table. So on reactant side, if you see how many magnesium is present, you will say 1. How many oxygen is present, you will say 2. Now check for product side. Magnesium is 1. Oxygen is also 1. So magnesium is balanced. What is not balanced over here is oxygen. So just to balance this, if we write MgO2, so this is going to be balanced. But we can never do this. Why? Because chemical formula which is there is always going to be in constant proportion. Their number is always going to be fixed. So this we cannot do. We cannot do this. But why so? How this MgO is only being formed? For that we need to understand how to write chemical formula. And for that you need to know the valency of these elements. Okay? So before we go to balancing, we will learn how we can form chemical formula. Okay? So for magnesium, you are aware of its valency is 2. But how can we say its valency is 2? Because its atomic number is 12. Okay, so its electronic configuration would be 282. This also we have already discussed in our previous classes, how electronic configuration is being prepared. In first orbit, maximum 2 electron will be there. In second orbit, 8, and the remaining will be going the next one. So here, last shell, since magnesium is being metal, it has tendency to donate electron. So it is able to donate maximum how many electron? It will be donating maximum 2 electrons only. That is why its valency is 2. Same way, if you see valency of oxygen. So oxygen has valency 2. How come this also has valency 2? Because atomic number of oxygen is 8. So its electronic configuration would be 2, 6. So now oxygen being non-metal, its tendency is to gain electron to complete its octet condition. Octet condition means it must have 8 electron in its last shell. So here it will gain 2 electron. That is why its valency is going to be based on this last shell. Its valency will be 2. Its valency is also 2. Now, if you remember, we have already done this crisscross method. Magnesium and oxygen, we are writing 2 for this magnesium, 2 for oxygen. So this is going here and this is going here. So this is called crisscross method and it is forming Mg2O2. Since they have same number of atoms, so we write MgO. We write magnesium oxide as MgO, not Mg2O2 or MgO2. So with this you can understand we cannot change the chemical formula. We cannot put MgO2. We have to put here MgO only. So now we will continue our balancing chemical equation. So see here, to balance this oxygen, I have to put 2. How can we put 2 here? If we are writing 2 here. Why? Because we cannot put 2 here. That we are aware of, it will change the chemical formula. So we have to put 2 here. Since this 2 is in front of this molecule, so this 2 is going to be for magnesium as well as for oxygen. So here we will multiply 2 for magnesium as well. Now you can see on product side we have 2 magnesium and 2 oxygen. So now is it balanced? No. On reactant side we have only 1 magnesium. So to balance this we have to put 2 here in front of magnesium as well. So now we can multiply this and simplify it. So 2 here also, here also. So you can see now on reactant side as well as on product side, everywhere it is balanced. On reactant side and product side, all the atoms of different elements are equal in number on reactant side. Okay, you can see here on reactant side as well as on product side, they are balanced. Okay, we can take one more example here. Suppose we have carbon dioxide when it is reacting with calcium hydroxide. Okay, calcium hydroxide. Okay, how this chemical formula is formed, I will remind you that also, because calcium has valency 2. Why so? Because atomic number of calcium is 20. So electronic configuration would be 2, 8, 8, 2. Okay. So last shell has 2 electrons. So it is metal. So it will donate 2 electron, and that is why its valency is 2. Same way, if you talk about hydroxide, you need to by heart that, because they are made up of polyatomic. They are made up of polyatomic ions. So this ion is made up of more than one atom. So here valency is 1. This you have to by heart. Okay. Since it is a metal, it will get positive charge. Being it is non-metal, you will give negative charge. Now you will do this crisscross and you see this calcium is getting 1. So Ca1, and this OH is getting 2. So we are writing OH2. But if you write OH2 this way, it shows that only hydrogen is 2 times. But it is entire OH. That is why you will be keeping a bracket. Okay, you will keep bracket. So here better way I can write. So this is going to form calcium hydroxide. So this is how this chemical formula has been formed. Now after this completion of the reaction, it will be forming calcium carbonate, because carbon dioxide is reacting with it, as well as water molecule. Okay. So here carbon dioxide reacting with calcium hydroxide to form calcium carbonate and water. So now we will check. I will erase this. Check again. This is the list of elements. Here reactants. This is the product. So elements, we have carbon, we have oxygen, we have calcium and hydrogen. How many carbons are there? You will say 1 on reactant side. How many oxygen is there? 2. Remember, you can see this oxygen is also twice. So it is better to write separately as 2. Okay, it helps in balancing. Calcium is 1. Hydrogen is how many times? Since it is in a bracket, so that is also 2. Now check on product side. Carbon is 1. Oxygen is how much? 3 plus 1. Calcium, if you see, it is also 1. Now hydrogen, if you see, it is 2. So if you simplify all these things, you see on reactant side and product side, they all are equal. So this equation is already balanced. Okay, so such type of chemical reactions are showing balanced chemical equation. Okay. We can take one more example. Suppose H2SO4 acid is reacting with NaOH. Here you can see sulfuric acid H2SO4 reacting with sodium hydroxide NaOH, and it is forming a salt named Na2SO4 plus water. This will do one more example how chemical formula is being formed. Hydrogen has valency 1 because it is in need of only one electron to complete its duplicate condition, because it has only one shell and only one electron is there. So it is in need of one electron only to make it 2. So hydrogen has valency 1. For sulfate, since it is polyatomic ion, you have to remember its valency, which is 2. Being negative, it is 2 minus and this is plus. You will do crisscross. 2 will go with hydrogen, so H2SO4 is getting 1. It is okay if you don't write. So this is how you are getting sulfuric acid. Okay, and same way in place of hydrogen you will have sodium. Just this way it is going to make Na2SO4, sodium sulfate. Okay. How we balance this? You will write elements, reactants and product. Element, reactant and product. Which elements are there here? Hydrogen, sulfur, oxygen, sodium. Okay, that's it. Now you see here. See, you need to remember one more thing. If entire polyatomic ion is going on that side, reactant and product side. So here, instead of writing sulfur, you can directly write here sulfate. This also you can do. Okay. So, but since it is beginning, we will go with individual atoms. So, how many hydrogens are there? You will write here 2 plus 1. You can see 1 hydrogen, 2 hydrogen. On product side, how many hydrogens are there? 2. Sulfur is how many? 1. Over there, sulfur is 1. Oxygen is how many here? It is 4 plus 1. 4 here, 1 is here. There also 4 plus 1. 4 here, 1 with water. Sodium, if you see, it is 1 on this side, over there it is 2. So you can see here hydrogen is not balanced because it is 2 plus 1, 3, over there it is 2. Oxygen is also balanced here, if you see, 4 plus 1, 5, 4 plus 1, 5, and sodium is not balanced. So if we try to balance sodium over here, so I have to multiply 2 and this 2 will be going here. But when I am keeping 2 here, this 2 is going with this 1 of the oxygen. This 2 is going with 1 of this hydrogen. Okay, you can see this hydrogen is 1 in number. So 2 will go there also and here you can see. Okay. Now, if you see, we balance this sodium, but hydrogen have become 4, 2 plus 2 ones are 2, 2, 2 plus 2, 4. And here oxygen also, if you see, it has become 4 plus 2, 6. So now, if you see, your sulfur is already balanced, sodium you balance. You need to check about hydrogen. You can see this hydrogen and oxygen, they are not balanced. So check on reactant and product side where you can do that, where it is less in number. So on reactant side they are already more in number. So we need to think about product side. So what should I do to balance this hydrogen? If I multiply 2, so this will become 2 plus 2 this is becoming 4, and here when I multiply 2 over here, it is becoming 2 2s are 4. So now my hydrogen is also balanced. Since this 2 is kept here, it is giving 2 oxygen, 2 for oxygen also. So now at oxygen level also I will keep 2. You can see this 2 when I keep, it is making hydrogen 2 2s are 4, as well as oxygen is also 2 times. So now check whether it is balanced or not. So yes, this has also become 6. So your oxygen is also balanced. So this is how you balance chemical equation. You can practice many more such chemical equation. Okay, and at the end we will see hit and trial method. So here you see, if you use hit and trial method, for example, when hydrochloric acid is treated with NaHCO3, sodium bicarbonate or sodium hydrogen carbonate, it will form sodium chloride, water and carbon dioxide. So here we are going to use hit and trial method. So what you need to do, you need to just check whether it is balanced or not. See, one hydrogen, one hydrogen. So on reactant side it is 2. Same it is there on product side. Check for sodium, 1 in number, 1 in number. It is balanced. Chlorine, 1 in number, 1 in number, balance. Carbon, 1 in number on reactant side, 1 in number on this side. Oxygen, this is 3 on reactant side, 2 plus 1, 3 on product side. So this is how it is a balanced chemical equation. But if we take some other example, say hydrochloric acid reacting with sodium carbonate, it is forming NaCl plus water and carbon dioxide. So here you see hydrogen is not balanced, it is 1 in number, over there it is 2. Carbon 1 in number, 1 in number, it is balanced. Chlorine is balanced because it is 1, here also it is 1. Okay. So now if we have to balance this, same way check for sodium, it is 2 in number, here it is 1. So since sodium is 2, I will put 2 over here. So now sodium is balanced. But you check here, when I keep this 2 here, this chlorine is also becoming 2 in number. So I have to put 2 on this side. So your chlorine is now twice. Hydrogen is also becoming twice. And hydrogen over there is already 2 in number. Check for other thing. So chlorine is balanced, hydrogen is balanced, sodium is balanced. Check for carbon, already balanced. Oxygen is 3 in number, here also 1 plus 2, 3. So this is hit and trial method, children. By practice you can do it directly without making that table. So now this chemical equation is balanced. Okay. If many more doubts are there, you can discuss later.